Hello, everyone. On behalf of the Melbourne Data Analytics Platform, or MDAP, welcome here. Let's begin with the acknowledgement of country. We acknowledge the Aboriginal and Torres Strait Islander people as the traditional owners of the unceded lands on which we work, learn, and live. We pay respects to elders past, present, and future, and acknowledge the importance of Indigenous knowledge in the academy. As a community of researchers, teachers, professional staff, and students, we are privileged to work and learn every day with Indigenous colleagues and partners. Hello, everyone. It's my great pleasure in presenting Professor James Smithies here today as part of the MDAP seminar series. Many of you will know him. He's a legend in his own right. James is currently the director of the HAS Digital Research Hub at the ANU. He was previously Professor of Digital Humanities at King's College London, the founding director of King's Digital Lab, and the deputy director of King's eResearch. He has also worked in the government and commercial IT sectors in United Kingdom and New Zealand. He's a historian of culture, ideas, and technology with expertise in research software engineering, applying computational tools and methods to arts, humanities, and social sciences. Without further ado, I will see talking rights, and please let us welcome James here today.
Thank you, Usha. It's lovely to be here and see some familiar faces. I'll be talking today about the technical side of my work. I also do sort of history of ideas, but this is I'll be providing a talk about my technical project today. So, right, juggling slides. I'd like to acknowledge the traditional owners of the unceded land on which we work as well. These are communities who have been managing technology in a sustainable way for 60,000 years. And something I think the software industry could benefit from. And in terms of research software engineering in Australasia, I think it's something that we should take inspiration from. Right, so today, I'm going to talk about a project that I've been running with Glenn Berman here for, a year? The AI's infrastructure project. So this was sort of born in the first flush of ChatGPT hype. I had some research funding and thought I better do something with LLMs, and this project emerged from it. I'll contextualize the project, the project output that I'll be describing in the context of research software test engineering, which no one talks about, and I think we need to talk about more. I'll be talking about this output that we've produced or hacked together, really. Atlas, it's the analysis and testing of language models for archival systems. It's a test harness. So the AI's infrastructure project has been running, it's going to run from 24 to 26, using personal research funding that ANU kindly provided me when I started in 24. There's a website you can have a look at. It's a transnational project involving the UK, Australia, and Aotearoa, New Zealand. And we're using Hansard debates from 1901, as obviously a nod to Australia, as our content baseline to test the use of LLMs for historical research. Partners grounded in our new HAS Digital Research Hub at ANU. We also have the ANU Library involved, Aotearoa New Zealand Department of Internal Affairs, who look after the GLAM sector in New Zealand. Australian Parliamentary Library, King's College London. We've got a couple of colleagues at King's who are involved in the project too. National Library of Australia, UK History of Parliament project, who digitise and look after UK Hansard, and the UK National Archives, who are taking possession of UK Hansard. In terms of principles, remember this was sort of the first flush of this latest AI hype. So how do we engage with LLMs and test them and experiment with them, work out how to evaluate them in an appropriately scholarly way. We thought we need some principles. I really wanted to focus on the digital humanities tradition of open source technology and experimentation. My concern was that with this next phase of AI, that everything was becoming so complex and large scale that we wouldn't be able to work with open source code and hack things together and own the technology, that we would have to outsource, or we may have to outsource everything to the large technology vendors. So I wanted to test that. We also wanted to engage in principles of slow AI that were emerging at the time and are still developing. This notion that instead of rushing to put something out or just use the latest technology, we should think carefully about it. Care principles for Indigenous data governance, obviously, fair principles for research data management, and initiatives, a wide range of other initiatives around responsible AI, which Glenn is an expert in. So the goals are not primarily the Atlas test harness that I'll be discussing today or describing today. Our goals are sort of larger scale than that. We wanted to identify and implement best practices for the design, development, evaluation, and maintenance of historical research tools, which can broaden to HAS research tools in general, but we wanted to limit the scope as much as possible, enabled by large language models. So the idea is that we have this rapid, agile project using personal research funding. It's primarily just me, Glenn, a senior research officer, and Karaitiana Taiuru, who's an Indigenous consultant, expert in Maori AI from New Zealand. And then we have an advisory board chaired by Stephen Fox, who's the parliamentary librarian. And I should say that the advisory board are providing us with just exceptional support. It's really, the three of us are driving this thing, but every now and again we'll have an advisory board meeting and we're told that we're doing something significant and useful. It sort of stops us just turning it into a dinky little project. But yeah, so primarily though, we want to develop an evaluation framework to support the responsible implementation of AI tools in the GLAM and academic sector. So it's based on this assumption that senior managers, but also academics, are confronted with these new AI tools, and we don't even know what they are. We certainly don't know how to evaluate them in terms of sort of bringing them into our research practices. So what are they in, I guess, philosophical terms, but also how do we judge them, not just in terms of performance, so the output they provide, but also in terms of environmental impact, issues around ethics, cultural identity, gender bias, all the rest of it. These are sort of evaluation metrics that the commercial sector isn't going to be so interested in, and it really behooves us to develop these frameworks. So we're going to try and develop that sort of framework. And in order to do that, we thought we'd develop a prototype technical test harness that we can use as ground truth, as well as to work out whether we can still develop using open source tools. Because that evaluation framework, it's also about, we also need to evaluate these tools in terms of whether we have control of the technology or whether we have to outsource expertise to large vendors who might not have the same values as us. And beyond all of this, the hope is that we can build capacity and understanding of research software test engineering. So research software test engineering, what is this? I've worked in test engineering teams in the government sector and had great fun with them. They're really fun teams to work with because they try and break stuff primarily. And so this is, I guess, a bit of a digression, but I'm viewing the work we're doing with the Atlas test harness through this lens of what we might call research software test engineering as a practice that we need to develop. And I will go so far as to say it's perhaps the essential skill set in an age of commercial capture of AI and vibe coding. Even if they take away our ability to code, they can't take away our ability to test, evaluate, critique. And software test engineering is tightly connected to the history of computer science proper. It has a really rich history. And in fact, the history of computer science is intricated with test engineering. They're sort of the same thing, really, although in large technical teams, they'll have a test team and a development team, and they sort of perform different functions. But historically, the same thing. So, we have the Harvard Mark II computer bug, literally a bug. It's sort of apocryphal, this story, but still, the idea that there's a bug found in this big old machine in 1947, the first computer bug. We actually have a long literature associated with software test engineering as well. Glenford Myers, The Art of Software Testing, moves through the 1980s and into the 90s, where they start to develop these black box techniques, which are really important to AI, because a lot of the rhetoric that we're getting out of the humanities and social science is that these AI tools are a black box. And, shock horror, it means that we can't control them, we don't understand how they work. Well, actually, black box software testing has been sort of baked into the art of software testing for many decades. It doesn't mean that that you gain full visibility, but it provides techniques that allow you to know enough about the system to work out whether it's safe and performant. So what I'm suggesting is that we take these test engineering traditions and we try to port them into research software engineering, and the evaluation of research products. So beyond that, how do you port these computer science principles into humanities and social science? We decided we needed some principles to work from. And principles beyond just slow AI, etc. So these principles are informed by slow AI. But we wanted to develop some AI testing principles that were more in line with RSE approaches like the Turing Way, which is a handbook produced by the Alan Turing Institute in London, which provides methods for reproducible, ethical, collaborative research. But the idea is to establish some broader principles for research software test engineering for AI, rather than just playing with AI tools. I don't know if a lot of you will have gone to conferences and you see people doing papers on AI and they're just throwing stuff into ChatGPT. There's no structure, there's no scientific method behind it. It's just sort of throwing stuff at the wall. We need to build out more empirical scientific methods to help us. So our acronym, sorry, yet another acronym, H-strict. The H stands for human. So beyond red teaming, which you might have heard of, the sort of attempt to break these systems, jailbreak them, expose their issues. Beyond that, towards a wide range of humanistic values, ethics, and standards in the evaluation of AI products and services. S is for system targets. So we need to ensure that testing captures the full breadth of socio-technical components, both deterministic and non-deterministic. So this assumes, rather than just testing models, we test systems. We hear a lot about foundation models. We forget the fact that ChatGPT is just a web app that has a whole bunch of things, assumptions and design assumptions built into it that we should be interrogating as well. Need to be transparent. So the various points of calibration for each system that you're testing should be transparently exposed to the tester and any users and documented for each test run. So again, you use ChatGPT or Claude, you can't really see the settings, can you? You're just an end user, which means that it's not reproducible. You could use it again in a month, and the settings have changed behind the scenes, but you don't know. Reproducible, obviously. Our understanding of reproducibility needs to change to facilitate the probabilistic nature of foundation models. So moving toward, the only way around this is to move towards a large-scale quantitative analysis as well as qualitative. I think those HASS traditions of qualitative subjective assessment is really important, but the only way to really understand probabilistic output is to scale things. You do that through iteration. So we need to establish baselines in testing that we can then rerun in 5 years' time. So a lot of those conference papers that you see that are throwing stuff at ChatGPT, I mean, what does it actually mean? They're useful, but it's a response at a moment of time, and it's incomparable. If it was run again in 5 years' time, it's incomparable. There's no longitudinal sort of baseline established that we can test against. And that's sort of the goal of our project, this Atlas project in many ways, is like forget about, to some degree, the quality of the output, just establish a baseline longitudinal data set that we can test against over the long term. They need to be contextually informed measures and baselines as well. So we can only do that by establishing system targets and associated contextual baselines that generations of models can be tested against. So that example of the conference paper with ChatGPT, one year you use one example and one set of documents, and another year you use another. Our goal is to set the baseline content at Hansard 1901 across 3 countries, and then just run that again year after year. So the baseline content is sort of normalized. And then finally, T for tasks. So remember that this isn't, HAS and AI doesn't have to be empirical. So I suspect actually, despite building this thing, I suspect I'm going to use AI in my research workflow for serendipitous purposes and creative purposes, to experiment, throw stuff at the wall, get a response. Empirical output is only one end of the research continuum, isn't it? So when we're testing these AI systems, we need to be really sort of critically aware about what we want them to do in the context of our research project. No. Right. So I'll be talking about large language model retrieval augmented generation systems. This is what the Atlas test harness is. So for those of you who aren't up to speed with LLM-RAGs, I'll give you a bit of a primer. So LLM-RAG systems allow large language models to analyze specific bodies of, or corpora of documents, making them ostensibly of real value to humanities researchers. So, the idea is that you can put a large language model in front of a defined corpus of documents, and the model can become an expert interpreter of those documents. And the documents are uploaded into a vector store, which is just a database that creates mathematical representations of the content, and the semantic relationships within the corpus are captured in those mathematical vectors. And that's what the language model interacts with. So what we've done is we have a source processing side to the tool, where we take Hansard from 1901 in Australia, New Zealand, UK. And the reason we took the transnational approach was this notion of, the potential for AI as infrastructure, getting around the problem of transnational infrastructure. So it's like, well, maybe instead of wiring together APIs between the National Archives and New Zealand National Library and the Parliamentary Library here, we just take the raw documents and convert them into mathematical weights, and that's our infrastructure. So AI as infrastructure. And that would mean that historians could take source documents from anywhere. You could compare, I don't know, we could add South American parliamentary debates to this, or medieval manuscripts. We've actually just implemented an instance of Atlas using Charles Darwin's letters. So people can query the letters against his book outputs. So there's something to think about, is that the development of the vector store is an art in itself. And there are a lot of research choices embedded in that. But then basically you just have this user interface, a chat interface, that has some Python code in our case, that goes out to the foundation model, and the foundation model looks at the vector store, retrieves an answer, retrieves content from it, and returns an answer. So there's a possibility that researchers could find ourselves using dozens of different expert large language models across a wide range of subject areas. And of course, there are commercial products that do this anyway. You can upload PDFs into Google Notebook LM, for example, and it'll create audio podcasts for you. But it's all opaque. And prices are changing. I'll get onto that down the track. But the context windows, the amount of content that you can throw at the LLM is still limited. It's growing all the time, but it's actually still not adequate for large-scale corpuses. Even our small one, just 1 year of Hansard across the 3 countries, has 11 million tokens. So that's beyond, even a little corpus like that is beyond the scope of current commercial offerings. The trade-off is that the RAG systems only send a small subset of the corpus. It's known as the fetch K in some instances for analysis to the large language model. So there are trade-offs in this. You're not sending all 11 million tokens. You're sending a very small percentage to the LLM for analysis. But it means that the price of the query goes through the floor. So if we were going to send all of that corpus to that large language model, and for the model to analyze the whole thing, it will cost something between sort of $200 or $1,000 per query. But using this system, it reduces it to 3 cents. But this is why I think, we need to think about these in terms of systems. The analysis of the models and the benchmarking of the models, how well it does in maths is important. But as soon as you start thinking of it in terms of systemic terms, the socio-technical complexity that has to factor in cost and accessibility and ethics cascades, and it turns it into a very humanities, social science level problem to my mind. Yeah. Right. So this is outside the scope of this talk, but I'm fascinated by the implication of harnessing these things. So I've just sort of touched on some of the complexity that we need to acknowledge. I'm fascinated by the implications of harnessing these kinds of complex systems in a way that makes them tractable to humanistic analysis. I love the philosophy of technology. What do we make of a system like that? And I guess ontological terms, like what is it in italics? And test harnesses are well known in computer science circles. They're sort of quotidian parts of the engineering process. But they have some really evocative connotations in the context of the humanities. The harness is an ancient technological object. Great power and importance to human history. Archaic definitions refer to the defensive equipment of an armed horseman. Figurative uses include references to the routine of daily work, which sort of seems apposite here. From the 16th to the 19th century, the word was used to refer to the apparatus in a loom that allowed the sets of warp threads to shift, which is rich in meaning for the history of weaving, but also, as Alexander Galloway has shown, computing. Computing's really allied to weaving as an art, jacquard looms, etc. But perhaps the richest connotation in the present context is reference to the trappings or accoutrements of a horse, including the gear or tackle of a draft horse or other animal. So let's not look at AI testing as something purely technical or, even futuristic. It's a deeply human process with roots into the deep past. And when you think of the idea of, I love this picture, the sort of Egyptian, the plow, harnessing nature, harnessing animals and domesticating animals. I'm not going to get into the whole sentient AI nonsense, whatever that is. But there's something really interesting if you anthropomorphize AI, if you're that way inclined, and even just thinking about the relationship of humans to AI, the idea of harnessing and the harness doesn't anchor us in the present. it gives us millennia of humanistic tradition that we can lean on in order to understand these things. But first, we have to understand the socio-technical complexity and manage that in some way. Right. So brass tacks. What are we trying to put into harness? I mean, this is a fun thing. We're trying to harness a LLM-RAG system. But beyond that, not much really. Despite the complexity of the underlying system, Atlas is just a web app that allows users to chat with their documents and provide feedback. The trick is that it's built with open source technology, so we have control over how it works and can create more transparency to help us understand what's happening under the hood. Like if there's an existential risk in our moment with AI, there's all the stuff we know, automation, unemployment, those existential and worse existential risks. For me, as a digital humanities person, the real risk is that we lose agency over code. Since the 1960s, humanities and social science have foregrounded hacking and having agency with code to be able to build stuff that the vendors don't want to build. And if we lose that, we lose everything. My current feeling is that we do have agency. I think the scale and cost issues, but in terms of hacking together systems and prototypes, we're still there. We still have that control. So this is the interface of Atlas that has been built. I mean, I'm responsible for it. It's live now, so let's hope it doesn't fall over or not work. It's a touch wood. I'm an amateur programmer, self-taught. Heavy use of AI coding tools, which is very meta. So we've built an AI test harness using AI coding tools. But the actual technologies are fairly garden variety. The foundation models that you can swap in and out are obviously advanced, but the actual system is just Python. There's a Python framework called LangChain, which allows Python to work with foundation models. So we're using that. Fast API, which is a web framework, a back-end framework. Vue, which is a front-end framework. Chroma database, it's just a really generic database system for vector stores. Redis, which is another type of database. It's actually used in the commercial world, but it's open source. We use that as well. And Amazon Web Services for authentication. So these are industry tools, but they're generic, they're open source. As an amateur programmer, I've been able to use them and build this thing. And the code is available online, open source. So it's a bit complex to get going, but anyone can download it and boot this thing up, create their own vector store with their own documents and experiment in the way that we are. The sign-in, by the way, with AWS Cognito is to support data privacy. So we wanted to test this thing with experts, and we wanted those experts, including Indigenous experts, to be able to work privately and query it and test it in a way that wasn't traceable. So people log on, but their identities aren't tracked. It's anonymous, but we've thought about data privacy. Right, so significantly for researchers and GLAM sector institutions wanting to create expert AI systems using subsets of their historical archives, open source tools allow for the creation of multiple bespoke vector stores. And I love this. This is the AI as infrastructure thing. The idea that in the future, and you can do it now with these commercial services, you go to the National Archives or wherever, download some documents, upload it to a vector store, and have an AI talk to your documents. So that's wonderful. If you've got control over the code, you've got a level of scholarly transparency and reproducibility that, to my mind, equates to footnotes. I'm a historian by trade. If I go into an archive and I take a document, I want a footnote associated with it. When I've got my technical hat on, my digital humanities, social science hat on, I want the equivalent in code. So in our case, this meant we could use historically accurate word embeddings as well. Now, this is key. So you create these vector stores, you upload documents to, say, Google. It turns them into mathematical vectors, but it uses a word embedding that will probably, almost certainly, be trained on contemporary language. So the semantic associations within that vector store are grounded in contemporary semantics. So what we were able to do, because we've got control of the code, was you develop a vector store trained on that uses word embeddings from the 19th century, using the Living with Machines. These are word embeddings created by the Living with Machines project in the UK. Is trained over something like 1 billion tokens in the British Library. And the word embeddings are designed for 1890 to 1900. So supposedly we'd need to test this. This is a question. You create a vector store with historically appropriate word embeddings. Does it create better quality outputs than a vector store created with contemporary embeddings? Or does it not matter because the AIs are so powerful that they'll just run roughshod over those details? But still, it offers, code offers granular control over the vector store design, even from chunking strategies. So when you upload the documents into the vector store, you get to choose whether the chunks that produces chunks, whether the chunks are 1,000 tokens or 50 tokens or 200 tokens. And depending on the size of the chunks, the size of the chunks will determine to some degree the quality of the output again. So we're sort of defaulted to 1,000 chunks and 100 overlap. Technical details seems to work well enough. But we need to capture all of those settings in amber, really, to be able to compare it with different settings. So when you're creating the vector store for Hansard, is it better to have chunks of 1,000 tokens or 200 tokens? Seems to me that 1,000 tokens works better because the debates are often quite short and a lot of the content, there's issues with the content. But you don't get to make those sorts of choices if you just press upload into Google. So the key design philosophy of Atlas is that we should have control over the code. And as I said, we've created a vector store of Charles Darwin's letters as well so that we can compare. Yep, so this is a small historical corpus. This is Redis, the database. We've actually changed the database now, but anyway, this is what it looks like in Redis. So we have 200 files. Those files have been turned into 95,000 chunks within the database. It amounts to 74,000 characters, about 13 million words, and turns out about 3 cents a query. When the sources are uploaded to the vector store, we tag them with different metadata tags for Australia, New Zealand, the UK. So we can compare and contrast across the different chunks. So using open source tools also allow for control over the models used in each of the test targets, as we call it, including open models run locally. So if you just upload your documents to Google, you're using Google models, our system can swap out any different model, including some of these Chinese models, for example, that seem really, performant for humanities and social science research. So what it means is that this tool can be open source code using an open source model running on your local computer. You have complete control. There's issues with that because running a local model on your computer, you'll have a much smaller model and it won't be as high quality. But in the future, it shows a sort of, I guess, a pathway, a future pathway that might mean that we can have complete control over these things. Probably, and it's what we do, we're going to be outsourcing the foundation models because they're just too big and powerful and costly for us to be able to run locally or even necessarily on university infrastructure. So we just choose between Anthropic or OpenAI or whatever we want. So you can see down the side of the sidebar of the Atlas tool, we define a test target, and this is like setting the system in amber. So all of these dials and levers that I've spoken about, the back-end vector store, the model that we're using, the system prompt, it's all there in a test target. We can test against that, change the settings, and then compare the two test targets against each other. So they also allow, open source tools allow control over the system prompt. So this is the system prompt. You've probably seen them in ChatGPT and other online systems. You can, the system prompt tells the system how to respond. So we've told the system in the system prompt that it's an expert historical research assistant for Hansard, given it some instructions about how to respond, how to deal with citations, trying to embed scholarly values, I guess, into it. Now, ideally, again, in terms of testing, you would test that system prompt against another system prompt and see how it performs. In reality, I'm not sure that it's going to be, that black and white, but, and the system prompt's really interesting too, and it raises really interesting questions in terms of programming. I'm at a stage where I sometimes I think that I have to upgrade the code. I'm like, because, it's code and I'm an amateur. And then I talk to an AI. I've sort of got this AI engineering team. Oh, I talk to the AI and it's like, just update the system prompt. So you come to the system prompt, natural language, and the performance improves. So we've got these, these hybrid deterministic systems with the code and indeterministic probabilistic systems that you can program with natural language. It's a very odd world we're living in. We've also implemented deterministic code that detects the context of the question, allowing for the implementation of culturally specific guardrails. So this is sort of the slow AI care, thinking about Indigenous data sovereignty, for example. So this is just, really straightforward code. It's just a stub, really. It checks whether New Zealand, Australia, UK is included. Those words are included in the question. And if it is, it only goes to the corpus in question, which makes sense, doesn't it? But what we could do is say it's just if then else. If Australia is mentioned in the question, or Indigenous, a set of Indigenous words are included in the question, then make sure your response is informed by principles of Indigenous data sovereignty. And this is sort of, a profound reason to keep pushing on these efforts to gain control over the code and not outsource things to large companies. I mean, again, it may be that in 2 years' time or 5 years' time, the AIs are so powerful that they just do that as a matter of course. But I think it behooves us to at least experiment with or understand how these protocols could potentially be embedded in these systems. So the UI is user interface is as simple and transparent as possible. And as part of a goal of actually using Atlas for education as well as testing, what I'd like to do is get in front of classrooms and use Atlas to teach students about the socio-technical complexity of these systems, the design choices that go into it, the dials and levers that the vendors are tweaking behind the scenes to produce these outputs. And also, because I'm a historian, I like books. I like footnotes. I love footnotes. I love articles. And, I like the idea of the interface being book-like for that reason. So we have citations that you can hover on. We have clarity around the different dials and levers. You can export the session to a JSON file. One day, it wouldn't be too difficult to implement. I'd like you to just be able to press on that button and have a citation in open repository, for example. So if you think about it, that's what we need, isn't it? There's nothing wrong with using these systems, even if they're probabilistic or give you an incorrect answer, so long as you can cite it. And when a researcher is reading your article or book, they can check that citation against the actual output, and ideally also the model that was used in the different calibration of the vector store, etc. At that point, research continues as usual. But until we get to that level of transparency, of scholarly transparency, then we're in an uncertain and worrying time. Yep. So users can see the full citations. So you can click on the citations and compare them to the answer. And these include links to the online canonical source as well. So if you click on the hyperlink, you'll go out to the online version of historic Hansard or UK Hansard to actually check it. And this is where it becomes useful for serendipitous purposes as well. I mean, whether the output's right or wrong, it might strike a chord and you can go out to the actual source and start exploring. Yep, so we can also, as I said, export our sessions. And this is an example of the export. It's just, for technical people, it's just the JSON export. And part of the reason for doing that was for citability and transparency, but we're also thinking about downstream analysis of the test results. Yep. So after this is where the test harness thing comes in, right? So if you're just playing with this stuff in ChatGPT, you can't capture the output, like it's difficult to rate it. So what we've done is, after the result is created and the citations are populated, a feedback box appears, and it's just thumbs up, thumbs down in this version of it. But we get the feedback. So we're creating focus groups of experts and Hansard experts within the project who can, in a structured way, assess the input and output of the system. So the next one is the extended feedback. So users can choose between the simple feedback, if they just want to, thumbs up, thumbs down, and simple text, or Likert scales, where so factual accuracy, analysis quality, relevance, difficulty of the question, clarity, and then there are also checkboxes for whether it's hallucinated, whether they think it's hallucinated or not. Quite onerous, really. We're asking these parliamentary librarians, really. This is the next phase of the project. We're giving them access to Atlas and asking them to test it in that structured way. And one of our goals is to produce a gold standard data set that can be used not only for analysis, but also fine-tuning of models. So in a way, this is an interesting point in time where we have these really quite huckery, they're like Heath Robinson machines, I reckon, these RAG systems. They're so complex and cobbled together. Ideally, their expertise would just be in the model. But what you can do is use these RAG systems to gather gold standard, ideally human responses, and then you use the resulting data set to fine-tune a model. So instead of going to OpenAI, ChatGPT version, whatever, you in the future could go to Hansard expert chatbot version, whatever, that's been trained on human feedback. So that's for the future. And I vibe coded this in an evening, this functionality. Just think like, oh, how are we going to ask these? It's actually, it really is quite onerous. You get a quite verbose response from the foundation model to a question about Hansard. And I've tried to tell the system prompt to not be so verbose, and it just sort of ignores me. So that's another thing. And then you've got 20 citations because we've got it set to use 20 documents. And actually, like, assessing those citations against the answer, as well as the general historical validity of the answer, it could take an afternoon for one question if you were going to really do it in a historically robust way. So, well, how can we help out? Oh, we're using AI. So there's an option in the system that we currently have hidden, where you can send the output off to a large language model, and the large language model will do the assessment and feedback. And it responds with what you're seeing on the screen here. It does its own assessment. So this is, instead of human feedback, it's AI feedback. And then that can guide the human reviewer to enter their human feedback. So they might think, well, it looks like the AI thinks that this, is sort of 4 out of 5 in terms of factual accuracy. I'll go along with that. Provides a bit of guidance. But we've turned that off for obvious reasons, because it muddies the data set. What we need is a data set of just human feedback. We'll bring in AI feedback down the track. Yeah, it's confounding and way too meta and circular. So another thing that people often don't know about every system that you use, whether it's Windows or Word, is that these systems produce what is it Shoshana Zuboff or some digital cultural studies person refers to as data exhaust, might be Paul Edwards, or telemetry, right? So everything you do is captured and sent off to some server so they can optimize the product. So they know that this piece of functionality is used a lot or not a lot and can be optimized. So Atlas does this. It captures the user telemetry, the questions and the answers and the feedback, and sends it off to the cloud system called Phoenix Arise. And you can see here the list down the side is actually code functions. So you enter a query, that'll be the top code that's set. And then this shows the system working through each of the pieces of code, producing the output, the user responding and rating it. And so we create this data set online. It uses a standard called open telemetry. So it shouldn't only be applicable to Phoenix Arise, it should be transferable. But this is sort of our core back-end database that captures all of the telemetry from the system, or a good amount of it. And we can then use that for different purposes to analyze what's happening. Yeah, so interestingly, these back-end telemetry systems, this is what the large vendors use, right? So the next version of the foundation model comes out, they've improved that based on user feedback, and they do not want, obviously, us to have that telemetry data. It's gold. It's the equivalent of Google Web Search, isn't it? Remember when the internet didn't look like it was, the World Wide Web didn't look like it'd be sustainable because they couldn't monetize it? But then they found that, well, if they have the data about our searches, they can tailor advertising to us. This is the equivalent in large language models. The telemetry behind the scenes allows them to improve the model. If you don't have that human feedback, thumbs up, thumbs down, you lose control over the future of the technology. So we have this here. It's tricky to get right. I think, I think it'll be good enough. And Glenn has pointed out that we can improve the quality of the data set again by implementing interrating. So what I'm working on at the moment is there'll be a first pass of human feedback the telemetry will go off to a rise. And then we're going to have another round of blind testing where another group of testers come along and interrate the initial feedback. And that should produce what even commercial vendors would view as a gold standard data set for fine-tuning. For fine-tuning a model for transnational Hansard for 1901 only. But the principle is this, the idea is to understand a workflow that would give us control over the full code and telemetry. Right, so that's quite a lot, but next steps. This production of Atlas has been a real rabbit hole, quite a fun one and an enlightening one, but the actual focus, as I mentioned at the start, is the definition of an evaluation framework for the Hass and Glam sectors. So the Atlas experiment has just created those cascading perspectives about that sort of inform how we want to evaluate these things, or how we recommend the Hass and Glam sector should evaluate these things. And Glenn's an expert in responsible AI, so we'll be taking the lead on developing that framework. And to do that, we're going to have focus groups in Aotearoa, Australia, and the United Kingdom, and they'll use Atlas, and we'll capture the data from that. And those focus groups will then inform this development of this larger evaluation framework. And beyond that, once we have those high quality data sets, we might look at fine tuning or other more advanced work. And final slide. So what are interim conclusions after jumping in the deep end? I'm happy to report, I mean, open source code remains essential for experimentation. We shouldn't give up, especially in terms of prototyping and understanding. Whether it can scale to production is a whole separate thing that may well be out of our reach, but open source code is still really important. Sustainability is a huge problem, but it always has been. So we just had to think through that. One of the biggest lessons for me is actually the freedom to develop bespoke vector stores is really significant. As a historian, working with sources is key to what we do, and that hasn't been taken away. It's less complex in many ways than the coding of the actual system, and definitely less problematic than producing the foundation models themselves. But, to be real, Atlas is a basic RAG implementation, and I think it probably would have been cutting edge about a year or 18 months ago. Now it's not. Like, there's things, semantic graph, they call it, or some semantic queries can be updated for semantic queries. The back-end retrieval system is fairly rudimentary at the moment, could be upgraded. We could also possibly implement agentic search. So that stub that I showed you, where it works out whether Australia, New Zealand, UK is mentioned, I mean, that could kick off a process that goes out and searches the World Wide Web, for example. But I think that the principles we've identified might be more useful than Atlas, actually. This idea of capturing things in amber and having a defined testing process is really significant. The educative and demystifying value of Atlas far outweighs its practical research value. I don't think it has the quality required to really be used in active historical research. But for educative purposes, it's great. And I think capturing telemetry is another compelling reason to build these test harnesses. And, to close on a slightly negative note, it might not be enough. The amount of resources going into AI, as we all know, in the commercial sector, and the fact that AI is sort of improving itself within the commercial sector means that in 6 months' time, this might all be moot. In a year's time, it might be moot. We'll see where we're at. So, the question I've got is whether in 6 months or a year's time, the AI, the foundation models are going to be powerful enough that this sort of bespoke work is moot. And that even the work we're doing to try and capture telemetry and come up with robust testing frameworks is going to be moot, because the difference between those dials and levers is like, doesn't really make any difference because the models are powerful enough. Yeah, and finally, moving from prototype to production is hard. So we've still just got a cardboard, what I would call a cardboard prototype. It's live and it can be used for focus groups, but there's no way you would implement it in a library or use it in a university setting beyond sort of educational, experimental purposes. So there you go. Thank you very much and welcome questions.
Blue testing. I mean, just going to check that no one's trying to come in the room. Yes, we've got time to look things. So questions for James. I'll give you the mic just for the Zoom audience, if that's okay.
Thank you. I've seen one of the comments that we can discuss something that we've thought on a lot of projects about this idea of archiving embeddings, because quite a lot of work to sort of having that as a data set that you can share and deploy be useful. One of the interesting challenges though is that embedding is only useful when you have the embedding model alongside it. Because for people that work with these, you can't sort of mix and match a sort of numerical representation of certain terms. You sort of have to stick with one model for all of your work, because otherwise. So how do you think we can approach sort of not just archiving the vectors, but sort of the models as well?
Yeah, good question. And this is where my technical expertise, need people like you involved in the project. I mean, we've implemented a hack, which is to basically just document the system state, and point to the word embeddings on Hugging Face or whatever. I mean, that's as good as we've come up with it at the moment. I don't know if that answers your question, but I mean, the sort of fine tuning and development of like word embeddings is beyond what we're focused on. We're very much just sort of end user product development, really.
I guess it was small.
But that's the question, isn't it? Is like, in terms of evaluating these things for research, what level of reproducibility or abstraction do we need to work at? And I would agree with you that ideally we get down to the level of actually archiving word embeddings and being able to reproduce the thing properly. But whether that's practical or not, or like where the pragmatic, where we are going to end up in pragmatic terms, I don't know. But I presume we are currently in that sort of, remember there was a black hole with the internet, it's still there. There's a period where people weren't saving or archiving websites and all of that's been lost. I presume we're in a similar space now, but I guess people aren't really using these things actively in research yet, as far as I know, certainly in the historical field.
Thank you. It's wonderful to hear about this project. So Daniel and I last year did much similar project, similar. 3 years in the 1860s, 5 Australian colonies and sons, 2 Canadian colonies and New Zealand. And I just wanted to, historian to ask you, why did you see the particular emphasis here? It's partly to facilitate study of change over time, which is historians to do, but also, for 20 years, the big buzz about translation history and similar things have place. So we've kind of got 3 axes. There's time, there's place. Initially, with what we did, I began asking it, look at debates about free trade and protection and tell me how they differed in Nova Scotia to South Australia, and it did a good job of that, but at first then I realised that it doesn't really understand it. It tells me, well, with some laws that this, but and then we have to go back to parliament and say, actually, a parliament is a place of people arguing with each other. It's completely confused. I just wondered if you had any observations about some training to understand actually what it is.
Well, that's a really good point. So presumably, I'm interested in whether we can use small models, because at the moment we're using large, just commercial models, whether we can use small open source models that don't have such background knowledge. The models we're using, Claude, for example, it knows what a parliament is, but it makes it difficult to work out whether it's using that background knowledge when it's answering. So the system prompt says only produce an answer based on the documents, but you can tell it's using that background knowledge. And that's sort of an open question for me is, frankly, as a historian, I find it useful. I don't trust the model, I go and check it myself, but it's useful to have a research assistant with a bit of background knowledge. But in other cases, this is the contextual thing, I would want a small model that doesn't have background knowledge and is just focused on the documents. So again, I think that's the reason to gain control over this and think about this in terms of the research workflow. And so there'll be different models for different use cases, effectively.
Any final question?
This is a really embarrassing question because could you sort of explain again a RAG system like for dummies, like it's retrieval augmented generation, but what does that mean?
And basically what you do is, so you have a web interface, you question and answer, right? Behind that, there's a large language model, so ChatGPT, say. And all you do is say that, instruct that ChatGPT to only derive its answer from a particular set of documents, right? So you constrain its answer to those documents, and the idea is that then it doesn't have to trawl through the whole of the internet that it normally does, and can provide more tailored, historically accurate answers. They use the word grounding, so it ensures that its answer is grounded in source documents.
So much. That was a wonderful talk. And there's so many things that stand out, that things like surveillance capitalism, digital gold, things like people's upticks and downticks going up as the new gold that you can mine for ads and stuff like that. I would argue that instead of it going irrelevant, it's actually going to be even more relevant as commercial black box models grow out there. They just start to get money. And we all know that commercial people can cut corners when it comes to that. And it gets even more black boxes. I would argue you need more of this than less of this, I would always get more relevant than less relevant. So thank you very much. Very, very lovely. Thank you everyone for joining us today.